Well, as promised, this is one of my favorite parts of the day that I've been looking forward to all day long. Welcome, Martin. This is Martin Fisher. He's the professor of civil and environmental engineering and computer science at Stanford University. He's also the director of the Center for Integrated Facility Engineering, a senior fellow of Precor Institute for Energy, and coordinator of the Building Energy Efficiency Research at the Precor Energy Efficiency Center. His research focuses on modeling, predicting, measuring, and improving life cycle performance in the built environment, and is a good partner with PPI. So Martin, we're not going to pinch you on your time. You have as much time as we allotted. We'll take it out of the panel discussion afterwards. So welcome and thank you for your efforts to pull this together. Look forward to what you have to share.
So no, thank you for having me again. Always great to participate in this symposium and this community. And it was great to see the work of Guillermo and Corey. And as you could see there already, it's a really excellent illustration of really the main point I would like to make is that in the future, well, I mean, in some ways already today, but in the future, much, much more so, the production systems we use on our projects to produce the digital work, to produce the physical work, on-site, off-site, in the office, is going to have to combine human and digital capabilities much, much more strongly than we see it today. You might say, well, come on, Martin, we're using already lots of computers everywhere. But the opportunity we have now, I think, as you can also see in your work, is to connect the different discipline phase silos much more through visualization, data integration, and automation, and in some extent, in some cases, even autonomy of what the machines do. And that is quite a new world that we are really entering. I would say so far we have been trying stuff. If I sort of extrapolate, put myself 10 years out, I think so far we have been experimenting. I think we will look back in 10 years and say, yeah, those were some cute applications we had. Now we're working at a totally different level. Yeah, and I think it's really this combination of human and digital capabilities that excites me. And we've coined this phrase together with PPI. We call this modern construction. So key question then is, why is blending and digital capabilities, blending of these capabilities so important? What are particularly interesting digital technologies? How will the roles of humans and digital technologies evolve? And then what are the strategic and operational management challenges for a production system and for a company that uses such production systems that blends human and digital capabilities seamlessly? I'll try to shed some light on these questions in my presentation. I mean, that's also a whole class, but hopefully enough to stimulate the panel discussion. So modern construction, I mentioned the term, is really brings together three main, most impactful trends that I think we see in our industry. Industrialization, really thinking about what is bespoke on a project and what can be standardized in terms of product organization process, what can be done offsite, onsite, but it's beyond just onsite, offsite. That's a big part of it. It relates also to the business model that is possible, enabled, required. So that's a really big trend we see everywhere in the world in all sectors of the industry. Autonomy, we see that increasingly that machines take agency, take things off our hands. Of course, there's also many challenges still with that. Self-driving cars might still take a little while to be fully self-driving, but in building or factory automation, we see certainly certain decisions being made just by the system based on data. And then the whole field of digitalization, which really enables autonomy and this industrialization, but also addresses other aspects of project production in terms of decision-making, for example, that project teams has to make. But I'll hopefully illustrate these elements a bit more and able to bring them together through, well, illustrations and then combination of those illustrations. But why is this so critical today? And just to remind us, I think there's significant challenges here. I don't really recall a period in my professional life when we've faced these kinds of challenges at this scale. I mean, for example, the expectations for our facilities in terms of their economic, environmental, social performance just keep going up. Of course, we always had the economic pressures, but now we need to also show great environmental and social performance, which rightfully so. But we don't always, most companies that I work with don't really have the project production systems in place to truly consider all of these aspects. Then huge demographic shifts in terms of across countries, but also if we just look at industrialized nations, our customers are changing, who the customer is, they're getting older, for example, etc. And engineers, builders are getting younger if you can attract them to your company. I mean, that's what I hear around the world. It's just the challenge of getting skilled workforce. So we have to come up with a very different way of making decisions on projects. You cannot rely in a few years, I think, maybe already today, on people that have had 20, 30 years experience. We need to find a system that allows younger people with less experience to still make good decisions. And that's certainly possible. I've seen dramatic increase in learning when we bring digital methods into the mix. But that's another reason why I think we need to find a blended production system between human and digital capabilities. And then resource availability in terms of materials, labor already mentioned, in some cases also equipment. So, and I'm sure there's more challenges, but these by themselves are already, I think, big enough challenges. But I think the good news is also that we have also dramatically greater possibilities today than, again, if I think back in my career, we've had. In terms of the three topics already mentioned, industrialization, right, raises the question and the opportunity in terms of where do we produce so we can have good productivity, safety, quality, reliability, can have a better resource use. And that relates then back to in the successful companies. They're blending that, of course, with changes in business model in terms of what it is that the company actually guarantees, or what it actually, how much of the value chain is actually covering. And it's interesting that I'm seeing kind of different strategies, some focusing on a part of the production, the overall production process, and others saying, no, now we have the opportunity to really control everything. And I see a successful company with both of those models. But this is a decision now that in engineering construction companies you have to make, because if you're an engineer and you have to compete with somebody that is offering an industrialized product, well, the engineering is included there. So how much can you charge for engineering when you're in a market segment where it comes for free with what somebody else is offering, just as an illustration. And then the autonomy, really advancements in basically control systems and with communication advancements and computer vision, for example, to create these rapid feedback loops that allow autonomy and continuous learning. I mean, that will continue to evolve, but in some parts of construction, we can already see autonomous devices deployed, as you will see. And then the whole world of digital with many, many technologies, from mobile to cloud optimization, the interaction between physical and virtual in around location, dimensional control, machine learning, AI, robotics, additive manufacturing, Internet of Things, and sensing more broadly, virtual reality, augmented reality, extended reality. These are some key technology that each one on their own already big deal, but actually coming into our world with innovations almost every day together. So I think you can see that we are looking at least that's what it seems to me, at quite a different world in terms of the challenges we have to address, but also how the means we have to address them. And this is not really something that we necessarily actually in academia know how to do, and industry. I'm not sure there's a company that actually is really on top of managing all of this. And I think this is where an organization like PPI, in my mind, is so important to bring us together and develop how we tackle these challenges and leverage these possibilities. So why is this a big deal? I mean, we are building projects today, but consider a few performance criteria here. Cost, right? When digital tools, they cost you cents per hour versus many, many dollars per hour. And I understand an hour in a computer is not the same as an hour by person, but when you have a person do something that could be done by a computer, that is a problem, looking at just the cost difference. Speed, we see typically when you digitize something, 10x or even more, 100x faster execution, opening up a whole world of possibilities in terms of, again, feedback loops, exploring options, and so on. Consistency, I don't know how else other than through the means of a mix of the industrialization, digitalization, and autonomy, we will get to something close to 6 Sigma, well, even 2 Sigma, let's say, performance on our projects. That would already be, I think, quite amazing if you got to 2 Sigma. But I don't know how else to create highly consistent, reliable performance. And the same with scalability. Purely human practices scale very slowly and imperfectly. I think we all know that. And when we couple digital and human capabilities, we have a much better chance of actually scaling good practices. We already saw from the challenges, we have to increase the scope of what we need to consider to make a good project. And again, that requires a new tool set that has to be data-driven, because it'll take us, each project manager, I mean, decades to just, take us decades to learn about the cost and schedule performance and quality and safety performance. But now we need to add the user perspective, environmental perspective, many other perspectives. And we simply cannot afford decades of building that experience, only basing decisions on our experiences. We need to create more systematic, data-driven ways of learning. Optimization, we have seen when we have been able to apply optimization methods, often a 10 to 50% improvement. And learning, I already touched on. Of course, we have our beliefs and our experiences, and I'm not saying we should not use them, but when we can couple them with insights we gain from truly analyzing what happened on a project or what could happen on a project, we are much better off. And everybody talks about continuous improvement, but in few places have I seen really a sound basis for that continuous improvement. And that's really what modern construction gives you, because it in a way forces you to establish a much more clear baseline and strategic vision where you want to go. And then decision making, I think I already kind of mentioned, do we just rely on experience or experience and facts? And I would rather rely on experience and facts, but then we have to create them. That would actually be a good metric on a project. How many decisions have you made just on the basis of experience, and how many on the basis of facts? Oh, sorry. Yeah. So let me give some examples of different digital technologies. I won't be able to do the many digital technologies really justice, but just to illustrate that. And then I'll share a framework that hopefully is helpful for you to manage this combination of digital and physical and human capabilities. So in this case, 7 professionals did a design review of a digester tank for wastewater treatment plant in San Francisco in virtual reality. And so the digital environment really helped bring the professionals together, gave them a shared experience, and led to a design, allowed the team to produce a design that works for all the stakeholders in a much more rapid way than in a typical, handoff kind of process that we see, unfortunately, too often. Producing a cost-optimal structural design required the development of new concepts of how to think about structural design and analysis, and also the aggregation of the material data, cost data, but also the erection and fabrication cost data. So all these costs could be considered from the very beginning of a project. And when we applied this to a project much more complex than the one shown in the picture, but for non-disclosure agreement reasons, we can't show the actual project. But when we applied that to an actual project, we saw that the integrated and optimized way of designing, concurrent way of designing this, producing this structural design, led to a structural design that was 10% more cost effective. And you can see that pretty much all of the savings are coming from the details. And when you, again, contrast this with a sequential process, you will probably not have access to those savings that come from the details, because you've probably locked in the overall sort of big stuff that needs to be, that makes up the structural system in the early design stages. And you might have been lucky and picked exactly the right components that lead to an efficient production process, but you might not have. In this particular project, they were not totally lucky, and there was an opportunity to save 10% basically in the detail. So by making the design concurrent, the detailed and the conceptual design concurrent, and analyzing many, many options, we can produce a cost optimal structural design. Or producing the best strategy, construction strategy. Similarly, the company, in this case Clark Pacific, wanted to know from the beginning of the project what is the best construction strategy. And best, I put it in quotation marks, because, you know, of course, there's duration, cost, idle time, resource utilization, consistency of that, and so on. And so there's many factors that played into what they considered best. But again, similarly to the structural design option, it was a matter of very rapidly iterating and consistently iterating on these construction strategies and trying different ideas, so that over the course of 3 days, these two professionals could come up with the best construction strategy for this project. In terms of producing a reliable construction process, a technology that has been out now for a couple of years, few years, is versatile, but there's other methods that allow you to very rapidly and consistently document what goes on a construction project. Here you learn what the crane is doing every second, and this allows you to really understand the variability in installation cycle times. Here, for example, for the shear walls on the parking structure, and this is actually quite surprising to me to see a variability of 23.5 minutes for the fastest and the slowest 111 minutes. So many of you have probably placed the dice game, where you sometimes may wonder, like, what, 1 to 6, that's a huge variability. Well, but that's actually what we see here in practice. But learning, right, what the variability actually is obviously a key part, and then creating a much more reliable production process, either through reducing the variability or finding the appropriate ways of buffering. Or building exactly what was designed. One way of this, this is for solar farm, fully autonomous layout of where the foundations for the different solar panels go. And so this drone flies around and basically does all of the layout automatically. And then so when we compared this with the traditional layout method, we saw significantly improved accuracy and dramatic time and cost reduction. In terms of actually producing work, so rebar tying robot for bridges is able to tie 1,200 ties per hour. That's slightly more than I did when I was a rebar layer. And again, seeing a significant improvement in safety, in particular ergonomics of the work, a reduction in rework, material waste, and still quite a significant schedule and cost reduction. So these are just very quick vignettes of some of the digital technologies that I mentioned at the beginning. And we are using them. We see around the world, everybody using, several of them. And I think now the challenge is to scale that use, but also then to really put all of this combination of digital and human capabilities together. And to do that, we reflected, and I should have highlighted on each slide, but the credits are there, the work of the students that helped do that work. And together with Ashwin Agrawal, able to put a framework together that at least I found quite helpful in thinking about this. Because if you think about any kind of production process, you need some data that you need to observe in some way. You need to typically analyze, predict a few things. You need to make decisions, and then you need to execute actions. And so in terms of, then we need to decide who does that and for what kind of task, who does that. So we could imagine at one end of the spectrum, a fully autonomous, automated way of doing things. The machine takes care of all of it. And then at the other end of the spectrum, we might have basically just a human doing things. That's sort of the baseline at the bottom. And then increasingly, you could say, well, there could be support of the digital methods for routine types of work. There could be routine autonomy. There could be support for non-routine work. And then there could be, like, the system can handle the digital methods, the machines can handle anything. So if we map the examples that I shared onto this framework, we see that, for example, the data collection system for the crane is offers collects basically data autonomously, and I think only in some, I would say, very non-routine situations does the human need to look at what's going on and add to the data. But most of the data is observed, collected, pretty much autonomously. In terms of the analyst role and the optimization examples, the optimization methods can handle sort of standard buildings, construction schedules. So extremely unique situations, probably not yet. So that's why I put it there in terms of, but in terms of providing routine autonomy. The virtual reality method basically provided support for decision making for a team of people. So that, in that sense, a bit lower level in terms of what the digital twin is doing. And then in terms of the autonomous or action executor, the drone really handles all of the layout. Drone really handles all routine situations and actually provides support for non-routine situations. And the rebar tying robot handles routine situations very well, but non-routine, sort of complex type of rebar designs, etc., humans still have to do. So if we generalize this, and the challenge you have and the opportunity you have in your companies is to decide of these types of production tasks in terms of gathering, observing data, making sense of the data, using it to make predictions, making decisions, and then actually executing the action for a particular situation. How much does the machine do and how much does the human do? And so therefore, how do you combine the digital and human capabilities? In this particular example, on the line shows that an automated, data is collected with some support of humans, but the humans still have the major role in actually collecting the data. Then once the data is collected, routine situations can be analyzed automatically, and also decisions suggested automatically, but then the implementation, the action is left to the humans. And the human is handling all of the non-routine situation in terms of analysis and decision-making, and also quite a bit of the data collection. Then you could use that as you say, well, this is what we have today. And then you could decide strategically, right, how do we want to change this? Do we want to create some level of autonomy in the execution? Do we want to be able to analyze non-routine situations? Is it important that we gather data more automatically? That's, in my mind, how you can then connect this blending of digital and human capabilities with your operational and strategic decisions. Because on the operation side, of course, you have to make sure that all of this is working, this blending of human and digital capabilities is working really well and consistently from project to project. Otherwise, we know what our project teams will do with the tools. So I hope these examples and reflections have explained to you what the opportunity we have with modern construction by really combining digitalization, autonomy in this industrialization, so that we can optimally combine human and digital capabilities in our project production system, because I would say we can, but we also have to. Thanks for listening.
All right. Thank you, Martin. That was a lot to think about there. Before we move on and invite our other guests for the panel, I want to give you a 30-second plug on the partnership that we have with you around some education around these things. So maybe you could just talk about that briefly.
Yeah. So we have had the pleasure, and Guillermo is a graduate of that program, with PPI and SPS for over a decade to deliver the virtual design and construction program, created and delivered globally to thousands of people on every continent in every role. And really what's needed now to move us further on, and that's still a very relevant program, of course, but what's needed now, which I hopefully was able to show a little bit, is a much stronger conceptual underpinning of how we produce work, how we plan it, how we manage it. And that's where really I'm thankful for PPI to have made me aware of operation science. And until a few years ago, you could have said, well, operation science, yeah, Martin, that's very nice, or Gary, or Berto. Yeah. Great theory. I have a project to build here. So, but now, as you could see, we can get the data, we can analyze the data, we can bring some autonomy to our projects. So now you have a choice of just continuing with the, I would say, pretty flimsy conceptual underpinning of construction management, or put construction management on a really sound footing, a conceptual footing. And that's what want to together teach. We hope that if this sounds interesting to you, get in touch with Gary, me, yeah.
And we'll work with you. Very good.